Now, did I see someone there? Yeah, he's number 4. Okay. So we're recording this now. I'm going to go to OneNote and I'm going to show you what we need to do. This is the wrong one. We've got to go to MAT2. Should have set this up before. You know, I was doing something else on the computer and then I realized, oh, it's nearly time. So we want to have a look at coordinate geometry formula. Right, so just shift everything over so I can see the chats to the side and you can get back to me. Right, last time we did the midpoint and the distance formula. And note for the midpoint, you need to add the two things here. See how we have add here? And for the distance, you need to subtract, but you add in the middle. So make sure you do that and get those things out correct, because the midpoint we add and the distance we subtract the x values and y values, but we add in the middle. So you are actually not going to get the formulas necessarily, but today we're going to go on to the gradient formula and the straight line formula. So the gradient formula is y2 over y1, x2 over x1, and we again subtract. So how do you remember this, whether we add or subtract? I think I had a way that you did this. How did I teach my class last time? Distance you subtract, gradient you subtract. Yeah, the midpoint is the only one you add. So if I put add here, ADD, the third letter lines up with the D there, and that's one way of remembering it. Well, see how your third letter lines up with the D. The midpoint is the only one that you add. The distance, the third letter subtract starts with S. The gradient, you just got to remember it subtracts. Now don't use the third letter there, A for add. It's the D, that's add. The rest of the time we subtract. But distance, you have to subtract here, but you have to add your results and also square. Okay, so gradient is just change over y, change over x, and a straight line formula comes in two forms. You've probably seen this one, y equals mx plus c, but we also have y minus y1 equals gradient x minus x1. Those are other ways of looking at the straight line formula. So we'll go over these two at the beginning of the period. Now, did I prepare something for you here? I can't remember. We'll just use these examples that we've already got. So we've got this example. So what I'm going to do is I'm going to copy it again, and we're going to find the gradient and the straight line. So I will collect this here. If I hadn't been distracted, I would have prepared all this earlier. Even teachers can sometimes get a bit distracted. We've got that lined up pretty much with the grid. Okay, I'll just do a bit of erasing out of things that we don't need. We don't need these bits. Yeah, that's just a bit confusing. We don't need these bits. Whoops, let's undo that one. Okay, that's close enough, probably. Now, the midpoint formula, you know, is x1, x2, y1, y2. Well, we have the same thing for A. We're still going to call it x1 and y1. And B, we're going to call it x2 and y2, like we did before. Whoops, and I'm writing the wrong letter. We've got A and B here. We put the points in there. A is the point 2, 3, and I haven't got it very well lined up, have I? Well, let's just shift this whole thing so it lines up very well with the grid. That's what I had it lined up. Wrong pen. Just move it so it lines up perfectly so we can do our things properly. Oh, that's better. So x1 is 2 along and it's 3 high. I haven't got, why is that not right on the 3? I don't know what has happened here, but it's a little bit out of line. Okay, what I'm going to do is I'm going to start off with a proper one. We'll use a different one that lines up exactly on the grid. I don't know what's happened to these 1, 2, 3, 4. We'll just cross those out. And let's start all again. So we've got this as -1 here, that's -2, that's -3. Oh, those didn't even line up. I don't know what's happened here. Maybe it's because I scaled it. I don't know. I'm going to have to rub all those out. I'm going to have to start again now. Not even these lines are not good. Right, so let's go again. Here we've got -1, -2, -3. 1, 2, 3, 4, 5. And I've wasted your time this morning. I hope everyone has managed to find everything on the Google Sites okay, and getting your way around that. Okay, I'm going to put in a line. I'm going to draw a line, and we will work out the gradient. And, oh, whoops, so I'll go from there. Let's go from here to, say, here. So here's our line. I'm going to put the ends of the line in. So I'll mark it with this point here and this point here. I'm going to call the left one A and this one B. And again, A is going to be the point x1, y1. So this will be -4 here is my x value, and -2 is my y value. And B is the 0.55. So that's my x2 and my y2. We're going to do the gradient of this line. Now, gradient we normally just is the distance up over the distance along. So before I use the formula, I just want to make sure you know what the gradient is, because it's the slope of the line, distance along, and I start writing slope. So that's just distance up over a distance along. So let's count. If we start at A and we go up 1, 2, 3, 4, 5, 6, 7, we go up 7, and we go along to get to boys. So we've gone up 7, so we're at this point, and we go along 1, 2, 3, 4, 5, 6, 7, 8, 9. So we go along 9. So the gradient is 7/9. Now that's one way of doing the gradient, and that's fine, but we want to see if you can use the formula in this one. So the gradient formula is y2 minus y1 over x2 minus x1. Oops, and I write x2. Lots of mistakes this morning. So y2 is my 5 here, and y1 is -2. So I have to go 5 minus -2. And I have to divide that by 5 minus -4, my x values. That gives me a value of 7/9 because we add these, which is the same gradient, which is what we expect. Okay, I'm only going to do one example on gradient. Is that okay? Type in yes if you've got that. Lots of yeses there, so I'm not going to bore you. Now we're going to work out the formula for the line. And I'm going to use the easiest formula first. And this is the y equals m bracket x minus x1. Hold on, I think I have forgotten my formula. Where's the formula sheet? Formula, here it is. Go to the formula sheet. It's y minus y1 equals mx minus x1. I knew I'd forgotten something. So let's go back here. It is y minus y1. Right, now it's really important that you understand that these two bits, the y and the x, they don't change, but the other numbers do. Right, so we're always going to have the y and the x there, but the other numbers change. So we go y minus y1. So here's my y1 here, and here's my x1. So it's y minus -2 equals the gradient. We've worked out a 7/9. X stays the same, minus x1, which is -4. Now, we can leave it in this form. And that is sufficient. That is the easiest way to do it. We could use the other formula, which you're familiar with in year 11, which is y equals mx plus c. Either way, we have to work out the gradient first. Here, the y and the x also stay the same. They are part of your formula, y and the x. Also, the equal sign, that stays constant in all of this. So see, each one has a y and equals in the x, y equals x. So this one also will have y equals and an x. So what we do is we put the value in for y and x. We take one of the points, but we have to come back to this formula. Probably the easiest to do would be point B, because it's 5, 5. We won't get it mixed up. The y value is 5. The gradient is 7/9 times 5 plus c. Now we have to work out what the c value is. So that is 5 equals 35/9. Remember, we multiply only the top part of our fractions, plus c. So you work out what 5 minus 35/9 is on your calculator, because we are moving this fellow here, the 35/9. We're changing it from the right side to the left side, so it becomes negative. So on your calculator, work out what 5 minus 35/9 is. And that will be, that's 1 1/9. So C equals 1 1/9. So what I do here then is I write 1 1/9, or 1.111 equals C. And then I rewrite my equation out again. So I come right down here and I rewrite my equation with the y equals 5 7/9, isn't it? Equals 7/9 x plus 1 1/9. 1 1/9. So you can see that the left way of doing it, this way over here, using the formula y minus y1 equals mx minus x1, is easier than doing it y equals mx plus c. So you can do either ways or both ways of doing that. I will go on to the next bit just to teach you everything you need to know for this section. Then I'll set you some more work. Would you like another example on straight lines, working out the straight line? Just type in yes or no if you want another example. Have I got anyone? Yes or no? Hello, is anyone there? You all gone back to sleep? Have I lost contact? Yes, you'd like another example, right? Okay, so a couple of people. Okay, so you want another example. Thank you, otherwise I'll be going too fast. So that's good feedback. I like it when I get some feedback. I know where you are. and whether I'm going too fast or not. So let's draw another pair of axes. I've got a pair of yellow axes here, it'll be fine. And I'm going to, on here, I'm going to draw the points. 1, 2, 3, 4, 5, 6. Okay, I want some people to suggest some numbers between negative 5 and 6. The first 4 numbers I want to see, negative 5 and 6. Someone choose some numbers for me, please. Right, so we've got negative 4, that's going to be 1 point, and 5, good. And we need 2 other numbers. No one can think of a number from negative 6, 3, and another number, thank you, Merlin, negative 2. Okay, so negative 4 and 5, we've got to plot that point. Negative 4 and 5 looks like this point here. So I'm going to call that point A. So that's my x1, y1. And then 3, negative 2 is this point here. 2 down, because that's negative 2 there. And I'm going to call this point B. Now I want here, I want the gradient, and then I want the midpoint, not the midpoint, the equation of this line. So the first thing I want is the gradient. And then I want the equation of the line. So when you're thinking of how to do the gradient, I'm going to draw the gradient in. I'm going to draw the line in rather. So here is our line here. That's our line. So now I'm going to use my formula, which is y2 minus y1. I'm going to write the formula out again, over x2 minus x1. So this becomes y2 is negative 2 minus 5. x2, 3 minus negative 4. Now make sure you put that double negative in there. So that's negative 7 over 7, which equals negative 1. So I should be going down 1 along 1 for this, down 1 along 1. How did you people work that out? By random numbers. What a nice, easy example you've made it. Okay, so that there is called our gradient. The gradient is given the symbol m. Do you know why they use m for gradient? There's a good reason. G is normally used for a function and somewhere else in maths, so they use m for gradient. I think it's because a mountain. So you think of a mountain, a steep side going up, so m for mountain. That's why I use it for gradient, the slope of the mountain. Don't know whether that's true, but that's what I like to think. So we've got the gradient there. Now we're going to use the formula for the straight line. You can use y equals mx plus 1, but I'm going to use y minus y1 equals gradient x minus x1. Make sure it's in brackets. Then I just take the point, I leave the y. Remember, 2 parts of these equations stay exactly the same, and that is the y, the equals, and the x, well, 3 parts actually, and the brackets, of course, they stay the same. And you're just replacing the y1 and the x1. Oh, the minuses also, but they will change depending on the question. So let's do this here. We do y minus, what's y1 in this case? It must be 5 equals the gradient, which we know is negative 1. X minus x1. X minus, now the x1 is negative 4. So we get our formula for the line y minus 5 equals negative 1, x plus 4. And if you like, you can do y minus 5 equals negative x minus 4 by expanding out the brackets. But this form is good enough. If you've got it up to there, that's good enough for this thing. So that's working out the gradients and the equation of the lines. Now, if I take another line, so I'm going to go move on to the next bit. So if I reproduce this line here, this line here has a parallel gradient. So I'm just going to shift it up here. These are parallel lines, and so the gradients are going to be the same. We could test it, but hopefully that you can see that I go down one along one, down one along one, down one along one. So the gradients are the same all the way along. So parallel lines have the same gradients. What's happening here? Hold on, my pen's just given up. Parallel lines have the same gradient. So we express it like this: M1 equals M2, then the lines are parallel. So that's for parallel lines. M1 is the first gradient, M2 is the second gradient. And then perpendicular lines, a line that is perpendicular goes at 90 degrees. So I'm going to draw in a line that is perpendicular. I'll make it a different color. So this will have a gradient of +1. I think that will be perpendicular. And I'm going to change it to a purple line there. Make it fatter. So those have 90-degree angles in between them, and this is perpendicular. And we'll notice that the gradient is the opposite. It's up one along one. So perpendicular lines have gradients that multiply to -1. So that's the next thing you need to know, that perpendicular lines, now perpendicular means meet at right angles. So I'll put that underneath, meet at 90 degrees, right angles. Perpendicular lines have gradients that multiply to -1. How they write this in maths is like this. They have a gradient of one line times the gradient of the perpendicular. So that upside down t represents perpendicular equals -1. So let's have a look at the quick way of doing perpendicular lines. All right, so I'm going to put a gradient here. Whoops, that's not a very good straight line. And I have real trouble drawing freehand lines on this. I want to draw a grid here. Ah, that's not a freehand line either. Select it. Maybe this will work. Okay, now I'm going to draw here the perpendicular. So if I have a line that is 5, as a fraction that is 5/1, I turn it upside down, 1/5, and I put a negative there. So one is going to be positive and one is going to be negative. And they'll multiply now to -1. Let's do a few more examples. Say I have 1/3. The perpendicular gradient will be negative. Turn it upside down, 3/1. Now 3 is the same as 3/1. If I have a gradient that is -2/5, the perpendicular is going to be +5/2. So what we do is we just turn it upside down and we make it negative or positive. I'll just extend this line. Right, do I need to do any more? It's the reciprocal, yes. It's the negative reciprocal though. Yep, so Nushka, it's called the reciprocal, but the negative reciprocal. Okay, I'm going to give you a line here and I want you to tell me what is the reciprocal of this line. Right, if I put the line, say, 4, what is the gradient of this one here? And here's another one, -2/3. Dylan, you're correct. It is -1/4. That's the perpendicular gradient. And what's this one here? What's the gradient of the line? Perpendicular. And Dylan, you're correct, 3/2. Thank you, Amajit and others. Anushka. So I'm going to give you one more example, and then I'm going to finish the lesson. and you can go ahead and do the work. So if I just say a line goes through, I'm going to make it quite a tricky one. Okay, so we'll try and see if we can extend your brains this morning. A line AB has a perpendicular through the midpoint. So we're going to have to find our midpoint. Right, so I'm going to give you A equals 20 and 30, and I'm going to give you B equals 80 and negative 10. Okay, so we have to find the equation of the line, the perpendicular line. Right, so the first thing I want to do, number one, we're going to find the midpoint. Number two, I'm going to find the gradient of the line. Number three, I'm going to find the gradient of the line perpendicular. And then number four, I'm going to find the equation of the perpendicular line. Okay, so the four things we have to do. So midpoint. You can go ahead and do it if you know how to do it. Go ahead and work independently. Just turn me on mute, and so you can't hear me, or turn your sound down, and I will continue, and I'll do the midpoint for those who want it. The midpoint, we have got add, ADD. Yes, I have to add for the midpoint. So it's x1 plus x2 over 2, and y1 plus y2 over 2. That's my formula. So here's my x1 and there's my x2. Here's my y1 and my y2. So I'm going to do the midpoint here, and I'll write it down as still in green. x1 is 20 plus 80 over 2, and 30 plus negative 10 over 2. So my midpoint is the point 50, and just give me this, 50 and 10. So hopefully I've got my midpoint correct. So there I've found the midpoint. If you agree with me, just put a yes in there. Then I'm going to do the gradient. So the gradient is going to be change in y. So that's y2 minus y1. I don't see any yeses. I guess I must have got it wrong. No. x2 minus x1. So the gradient then is going to be, it's correct, thank you. Right, some of you have seen it's correct. So the gradient is going to be y2. So that's negative 10 minus 30 over x2 minus x1, 80 minus 60. That comes out as negative 40 over 20. Well, that was quite handy. Which equals negative 2. I gave you a nice, easy example. So the gradient is negative 2. So that's part 2 done. So we've done part 1, where we found the midpoint. We've done part 2. Now for part 3, I want the gradient of the midpoint. So part 3, I want the gradient of the midpoint. Who can give me the gradient of the midpoint? Gradient of the perpendicular. What am I saying? I want the gradient of the perpendicular. Sorry, not the midpoint. What's the gradient of the perpendicular? Not negative a half, Dylan, because we've already got a negative there. One must be negative and the other must, yes, 1/2. Thank you. So that's good for you pointing that out for everyone. So the gradient of the perpendicular is 1/2. You take this here, turn it upside down, make the negative positive. Remember, -2 is the same as 2/1, so we invert it, reciprocal, and we get rid of that. Then 4, find the equation of the perpendicular. Y minus y1 equals gradient x minus x1. And so we have y minus the y1. Where's my y1 here? 30 equals 1/2 of x minus, and the x1 is 20. We've done it. Wasn't the gradient -2/3? No, this is -40. -30 take -10 take away 30. Midpoint, do we add? No, we only, we're doing the gradient. Change in y. y2 minus y1. y2 is -10, y1. Now, Amajit, just check this. Got a question here. Isn't the gradient -2/3? y2 is -10. y1 is 30. So I put 30 in there, and there's a minus because we're subtracting the minus. So that becomes -40. And then we've got 80 take away 20. 80 take away, oh, I've got 80 take away 60. You're right. I've got 80. I did it in my head. Thank you. So we're going to change that. We're going to change that. We're going to change that. Embarrassing. And we just need to change that. Okay, so let's go and have a look at that. I made a mistake there. Thank you, Anushka. Someone's paying attention. 80 minus 20. I did it in my head. 80 minus 20 is 60, and I wrote down 60. Going too fast. So that is -2/3. Thank you. Amajit, top of the class today. So if it's -2/3, what is the gradient of the perpendicular then? (3/2), or 1.5, yes. So we just write 3/2 there, and we are finished. So there we've done the gradient of a line that is perpendicular through a midpoint. Now I've taken you right to merit level in 2 periods. This here is a merit level question because we're having to do several things all at once. We had to find a midpoint, which was first. We had to find a gradient, we had to find a perpendicular, then we had to find an equation. Okay, if you want extra help with this, you can stay and get extra help from me. Otherwise, I'm going to set you on, and I will be available till the end of the period. I'll be recording this. Sorry, I have recorded, I'll be uploading it. You should be able to go ahead and do, where is it, questions, altogether, using 2 points, gradient, and the equation of straight line. I gave you up to what, page 14 to do, didn't I? Yeah. So I think if you could go on and do pages 18 through to parallel perpendicular. In your book, pages 18 right through to pages 29, 30, 31. I don't expect you to do every example, but you've got the weekend to do all this. And so you've got pages 18 to 34 is what you really need to be working on now. You've got all the knowledge from pages to do, pages 18 to 34. I've covered all that material today. And don't do every example, right? Perhaps do every second example, or until it gets boring and you're getting it right. But if you're struggling, you may need to do more until you become comfortable with it. So try some from every page. If you get stuck on one page, don't think, oh, I'll just stop now. Go on to the other pages and you might make sense. come back and have a look at the videos. Remember that on the Google Sites class here, you have, wherever it is, on MAT2, coordinate geometry. On Google Sites, you have these videos on how to do coordinate geometry. If you didn't get any, if you didn't understand, go to coordinate geometry videos. There are exercises, there are instant marking. Continue on with Khan Academy because they have extra things on these as well. And I'll put some more exercises up there. You can go and look at those practice questions. That's for those who haven't got the book. Those who've got the book, you don't need to do these. You can go ahead and do the lesson, the workbook. Okay, I want to know if everyone's okay on that. And if you're okay, you have, whoops, where's my class gone? Have I clicked you off somewhere? Whoops. Where have you gone? Can't find you. Oh, here we go. Right. On here, I would like you, if you're okay and can do the work, you may go. If you're not okay, please stay behind.